The James Webb Space Telescope has done it again, and this time, it's rewriting the story of the early universe. Astronomers have uncovered a galaxy so ancient, so dazzling, and so unusual that it's turning established theories upside down. Meet Z14, not just the most distant galaxy ever recorded, but also one of the strangest. It boasts rare chemistry, an explosive luminosity, and yet, it's missing something we thought no galaxy could live without: a central black hole. Just as scientists were refining their ideas about how galaxies form and evolve, Z14 came along to upend everything. And here's the twist: this mysterious object might even support the wild idea that our entire universe exists inside a black hole. Z14 is tiny yet blindingly bright, and it dates back to when the cosmos was just 300 million years old. When Webb captured its light and revealed a redshift of Z equals 14.44, researchers could hardly believe it. But the real shock wasn't its distance, it was its absence of a black hole. No monstrous object lurks at its center, despite the fact that every active galaxy we know today has one. Even stranger, Z14's light contains unexpectedly high levels of nitrogen, a chemical signature that suggests multiple generations of stars had already lived and died there, far earlier than anyone thought possible. Z14 may be small, a trait consistent with its youth, yet its interior tells a very different story. It appears ancient, densely packed with stars, remarkably bright, and bafflingly, it lacks a central black hole. This strange mix of qualities has once again thrown astronomy into turmoil. Just as scientists were beginning to recover from the first wave of surprises brought by the James Webb Space Telescope, this tiny, ancient-looking galaxy has forced them to rethink what they thought they knew. What's astonishing is that Z14 is now being considered a key piece of evidence for one of the most mind-bending ideas in modern science, that our entire universe might exist inside a black hole. MOM Z14 has earned the title of the most impossible of impossible galaxies. One fact is undeniable: this is no ordinary galaxy. Even in today's cosmic era, such a galaxy would be an anomaly, a rare case of a system without the black hole that typically anchors its core. So far, astronomers have studied thousands of galaxies, and in every closely examined case, a black hole has been found at the center. Yet, at the very edge of the observable universe, JWST may have uncovered an exception. How can this be? And what could it mean? Ordinarily, a small, early universe galaxy without a black hole would be an exciting find, a potential window into the earliest stages of galaxy formation. After all, it's perfectly reasonable to imagine that some of the first galaxies formed before black holes emerged. But Z14 doesn't just fit neatly into that scenario, it challenges the very framework scientists use to explain it. This could offer researchers a crucial clue about how galaxies truly form. But there's a twist. While MOM Z14 may be small, it's far too complex, packed with structure, gas, and stars, to be considered a newborn galaxy. In fact, MOM Z14 is a cosmic misfit, the odd one out among already unusual galaxies spotted by the James Webb Space Telescope. Now, scientists face multiple puzzles, not just its age and lack of a central black hole, but also its unusual chemical makeup. The high levels of nitrogen hint that at least 2 or 3 generations of stars have already lived and died here. That means the galaxy has gone through several phases of evolution and, by today's standards, is anywhere from hundreds of millions to several billion years old. The absence of a black hole only deepens the mystery. Since such objects usually sit at the centers of galaxies, helping to regulate their growth and evolution, the big question is, was the black hole simply missed, or does MOM Z14 prove that galaxies can evolve through an entirely different path? It's a cosmic paradox. The early universe appears too crowded with such developed structures. So, let's step into the realm of particles, and imagine them racing through the young, fiery cosmos. As the cosmic frenzy subsided, particles began to slow down. Molecules started to form, giving rise to gases like hydrogen and helium. Compression redistributed forces throughout the expanding universe, steadily squeezing vast gas clouds until the very first stars, made almost entirely of gas, were born at their cores. Those early stars lived short, brilliant lives before burning out, scattering dust across the cosmos. This dust thickened and compacted the surrounding gas clouds, making them spin faster and giving birth to longer-lived stars. Over time, so many stars filled the universe that gravity pulled them into clusters, which in turn merged to form galaxies. Up to this point, everything matched our researchers' expectations perfectly. From the Big Bang to our present-day blue planet, the sequence of time, gases, mechanisms, and cosmic connections had been reconstructed almost flawlessly. Then came the James Webb Space Telescope. Its observations revealed an early universe that seemed impossibly crowded, brimming with stars, dazzlingly bright, and far too chaotic. Galaxies like Z14 appeared in such numbers, brilliance, and chemical complexity that our scientists began running out of explanations. It's as if the universe itself is tearing up the old rulebook, urging scientists toward a new understanding. Yet, in JWST's images, these cosmic rebels appear as nothing more than tiny red dots, deceptively innocent-looking, yet posing some of the greatest challenges in modern astrophysics. The galaxies, of course, remain entirely indifferent. These compact, hyperactive galaxies were naturally scattered across the young universe, unconcerned with whether scientists on a distant planet, Earth, would be left in awe 13 billion years later. But could they be connected to an even stranger idea, the possibility that we might be living inside a black hole? This mind-bending theory, championed by physicist Nikodym Poplawski and others, suggests that so-called baby universes can form when matter collapses inside black holes, possibly including our own universe. The concept aligns with the turbulent, chaotic conditions researchers have now uncovered in the cosmos's earliest days. The roots of this idea stretch back to the early 20th century, to Schwarzschild cosmology. Among its proposals was a radical notion: black holes may not be mere dead ends, but gateways, origins of new spacetimes, portals to other realms, and even cradles for universes within a vast multiverse. So, what does all this have to do with Z14? If our universe was born inside a black hole, its earliest stages could have been far denser, hotter, and more turbulent than we've traditionally imagined. This scenario could explain why galaxies like Z14 formed so early with such intricate structures, as well as why there's such a wide variety of young galaxies. Interestingly, the absence of a central black hole in Z14 might suggest that gravity didn't work quite the same way in the early universe as it does now. Some theories, such as Einstein-Cartan gravity, propose additional effects like torsion. In this framework, the core of a black hole wouldn't be an infinitely small point, but rather a big bounce, a cosmic rebound. Our entire universe could have been born from such a rebound, nested within a higher-level mother universe. The fact that many galaxies seem to rotate in the same direction, a puzzling and seemingly illogical trend, might also hint at a large-scale, rotating origin system. This could be a kind of cosmic inheritance from that mother universe, whose collapse gave birth to our own. While these ideas aren't yet part of mainstream cosmology, they're gaining attention as older models fail to fully explain the strange realities astronomers are now observing. Simply revising the universe's age is no longer enough to account for the chaos and oddities found in the early cosmos. Speaking of which, let's explore 5 of the most bizarre galaxies discovered so far in the young universe, objects so exotic they leave scientists both baffled and thrilled. JADE's GS Z13-0, the record holder. With a redshift of Z equals 13.2, this galaxy once held the title of the most distant known galaxy in the universe. It existed just 300 million years after the Big Bang, making it a true dinosaur among galactic star islands. GN Z11, the Hubble veteran. Even before JWST began its mission, Hubble spotted GN Z11, pushing the limits of what was possible for its technology. The discovery of this unusually ancient galaxy initially raised doubts, some even suspected an observational error. After all, its presence just 400 million years after the Big Bang didn't quite align with the broader cosmic picture. 3. Sears, 93316, the premature giant.